Okay, great. Hi everyone, it's great to be here. Today I'm going to talk about app configuration, an emerging best practice to help you accelerate your software development. Now, if you've heard of feature flags, you can think of them as the tip of the app configuration iceberg. Now, the best way to understand what app configuration is to just see it in action. So let's imagine that we are a SaaS company called Potion. And if I switch to this app over here, this is our app, and this is the plans page of our app where users can subscribe to one of our paid subscription plans. Now, let's say the marketing team wants to run a 20% discount across all of our paid plans. Now, they ask us, the engineering team, for help. So we're going to go into our code base, and we'll implement the code for the discount. So we'll do that. And then we'll deploy this code to a staging environment and then send a staging link to our marketing team so they can have a look at what the discount looks like. So they have a look at the discount in the staging environment and they think it all looks good. So then they tell us as the engineers, okay, it looks good, let's deploy this to production. So we go back into our code base and we deploy this discount now to production. So we tell the marketing team, and then they confirm that, okay, now the discount's live, it's great. But a couple of days go past, and they decide that they want to pause this discount. So they come back to us, and they say, hey, can you stop the discount? So we have to go back into the code base, and then make the change to disable the discount, and then we deploy this to production, and then we tell them, and then they confirm, okay, it's paused. And now a few days pass, and then they say, okay, now we want to resume the discount. So at this point, we get pretty frustrated, and we decide to create a feature flag to let the marketing team turn the discount on and off themselves. So we've actually set up a feature flag system for this app already. So we're using a system called Hypertune. So we can go into the Hypertune UI now and create that feature flag. So we'll call it isDiscountEnabled, and it's a boolean because it's just on or off. And we'll leave it off for now, and we'll save that. And then we'll go into our code base and run npx hypertune to generate a type-safe client to access those flags. So we'll use the flag in the code now. So we'll call hypertune.isDiscountEnabled, and we'll pass a fallback value of false. So we'll deploy this to production, and then we'll tell the marketing team. And now they can go into the UI over here, and then just turn the discount on and off whenever they like. So right now it's off, so there's no discount, but they could just flip it on whenever they like, and then hit save, and then that discount appears. Now, they actually decide that they want to run this discount only in the UK for UK users. So they can actually do that here as well by adding a rule to check if the user's country is the UK and then enable the discount. Otherwise, by default, we'll keep it off. So now that they have this flag, there's no back and forth between marketing and us. They can flip it on whenever they like. They can control the targeting logic for the discount. And then we don't have to wait for the marketing team to tell us when they want the discount to be live. So our work streams are now decoupled, and so both of us can move a lot faster. They can also make these changes instantly. So whenever they make a change over here, it's updated in production instantly, and they don't have to wait for a code deployment or an app release. And they can also do things like A/B test the discount to see what impact it had on metrics they care about, like revenue or profit. So they can set up an A/B test here and then turn the discount on for half of users and then leave it off for the other half. So this system is working pretty great for them, and we don't hear from them for a while. But then one day, they tell us that they want to run a 40% discount instead of a 20% one. So we try and figure out what to do as engineers. We go into the code base and we see that the 20% discount is hard-coded. So what we could do is update this to 40% for them, but then we'd end up in that slow back and forth process that we had before we created this feature flag. So let's see if there's something that we can do to give them the control to change this percentage by themselves. So if we go back into the UI, one thing that we could do is, instead of returning just an on-off toggle here, we could return a whole discount object with subfields to say whether the discount is on, and another field to say what the percentage of the discount should be. So to do that, we'll head over into our schema and create a discount object type, and we'll add some fields. So one called isEnabled, set to a boolean to control whether the discount is on or off, and another field called percentage with a float type to control the percentage of the discount. So now that we've created this type, we can deprecate our simple boolean flag and create another flag which is just called discount. And instead of returning just an on or off to say whether the discount's on or off, we'll return a whole discount type or discount object. So we'll save that, and then we'll go into our code base and then rerun npx Hypertune to regenerate our client. And then you'll see the type error where we have that deprecated flag. So we'll replace that with the new flag, which is .discount .isEnabled. And then we'll also replace this hard-coded percentage with Hypertune.discount .percentage. And then we'll pass in a fallback value of 0. So we'll deploy all this to production. And now the marketing team can control whether the discount is on or off, just like before. But now they can also control the percentage of the discount. So they turn it on for everyone, and they set it to 40%. So if we save that, we can see that 40% discount applied now. But just like before, they can add complex rules to target the discount to specific users and even have different percentages for different users. So this is all working great, and they're pretty excited. But in their excitement, they say, can we have the ability to control the copy of the discount as well? So rather than just say summer sale here, can we test different bits of copy to see which works best? So we head over back into the schema for our discount, and we add another field here called name, and we'll set this to a string. And then we'll save that, and then we'll go back into our code base and then rerun npx Hypertune. And then we'll replace this hard-coded string here with that new field. So we'll set a fallback value of just discount. So we'll deploy this to production. And now, if we go back into the UI, you can see they can control the copy of the discount here as well. And this is pretty good timing because they want to run the discount for for users in France. So to do that, they can add a rule to select the user to check the user's country, and if it's France, they could return the discount copy in French as well. But for now, they just want to test a few different copies of their discount. So to do that, they can what they actually want to do is run an experiment to see which copy works best. So they can drop in an A/B test here. And they can define a few different variants. So they might want to test summer sale ends soon, summer sale ends today. But they don't want to wait for this experiment to run and go through like on all the steps of a traditional experiment where they have to kind of wait for the experiment to run, collect data, then see which variant won, and then take that winning variant and then ship it to 100%. So instead, what they do is they go to the experiment page, and they convert this ABC test into a machine learning loop so that we automatically converge on the best variant to maximize the number of upgrades. And then the machine learning loop also takes into account user attributes to learn if the best variant is different for different types of users. So now they're pretty happy with this system. They can control whether the discount is on, the percentage of the discount, the copy that we show next to the discount, and they can add complex rules and A/B test and use machine learning to personalize the copy. So we don't hear from them for a long while, but then one day they come to us with another complex use case. So they want to run a 20% discount for everybody, but then they also want to run a 10% discount for users who enter a special referral code. So we look at this problem and we see, okay, we're returning a single discount object from this flag. What we actually want to do now is return a list of discount objects so we can have multiple discounts running at the same time, which could be overlapping. So we deprecate this flag, and then we add another one called discounts, and this time we'll return a list of discounts. And we'll save that, and then we'll rerun npx Hypertune, and we'll get rid of the deprecated flag usages, and instead we'll use hypertune.discounts. We'll map over each discount and convert it into a plain JavaScript object, and then filter the discounts by whether they are enabled or not. And then we will calculate the total discount by just summing the amounts of the discounts. And we'll also update our code to render each discount as well. Cool, so we'll deploy this to production. And now we'll tell the marketing team that they can just add discounts here however they like. So they can add as many discounts as they like, and they can configure each of them how they want. So the first thing they do is they add a discount that runs on all users, and it will be for 20%, and this will just be the summer sale. So they save that, and then that appears in the app. And then they add another discount, but this time they only want to enable it if the user has entered a special referral code, LNUG, and we'll set that to 10%, and this will be the LNUG discount. So we'll save that. And now we'll see that the discount, the extra 10% discount isn't here, but if they enter that special referral code, then they get that extra discount as well. So they can do all the same things as before, so they can add complex rules for each discount to say when it should be on or off, change the percentages, change the copy, A/B test the percentage or copy, or A/B test the whole discount itself, or use machine learning to personalize the copy of discounts. So by evolving our simple Boolean feature flag into this flag which returns a list of discounts, we've empowered our marketing team with this flexible platform to manage discounts themselves. Cool, so let's switch back to the presentation. Cool, so we actually had an app configuration tool similar to the one that we've been using in the demo at Meta, and it was called Configurator. And it was used in quite a similar way to platformize products and backend services. And Meta actually released a paper on this called Holistic Configuration Management at Facebook. And it dives into how Configurator was used for lots of different use cases. For example, it was used to configure automated backend jobs, like user notifications, where you can configure templates for different notification types. It was used for pricing, billing, and discounts, like we've been showing in the demo. It was used to manage permissions and the features available to users, API rate limits, in-app copy for guidance, error messages, tooltips, modals, forms and wizards, metrics, health checks and alerts, search and ranking configuration, rules, policies, filters, and classification thresholds, machine learning model parameters and versioning, complex rollouts, kill switches and experiments, constants, API keys, third-party integration settings, and this large long tail of lots of niche configuration use cases. But across all of these use cases, we got the same high-level benefits. So number one, we decoupled dependencies in our organization so we could enable other teams to self-serve and make changes themselves without this slow back and forth process. And we could focus on shipping code to production without being blocked by other stakeholders. The second thing is we got instant updates, which were decoupled from code deployments and the release cycle. The third thing is once we had all of this configuration, we could optimize it with hand tuning, A/B testing, and machine learning. Fourth, we reduced complexity because we extracted all of this configuration logic, like user-specific code, out of different code bases and into a single source of truth. And we also got this clean separation of concerns between code and configuration. So we could focus on the high-level logic in our code and then worry about the configuration details later or just delegate that to another stakeholder. And then number 5, we got increased flexibility. So after writing our code, we could configure it in lots of different ways without any extra engineering work. So app configuration is great, but how do we go about building a general app configuration system that can scale to all the complex use cases that we talked about? So first we need a flexible type system to define the inputs going into our system, like the current environment or user, and then the outputs which are coming out of the system, like the feature flags or the discounts or the list of onboarding guides. The second thing we need is a flexible configuration language to define the logic that maps the inputs to the outputs. And we should be able to embed A/B tests and machine learning loops into our logic too. And then we need a UI for non-technical people to edit the logic visually. So when we combine those two ingredients, this flexible type system with this flexible visual configuration language, we can scale to all the complex use cases that we went through earlier. So this is really powerful, but it's also a bit scary as we're moving business logic out of our code base into a configuration system. So if the system fails or we make an incorrect change, it could cause major issues, like the one CrowdStrike experienced recently, or Cloudflare a while ago. Yeah. And we also don't want to impact the performance or efficiency of our app by depending on a configuration system. So how can we make the configuration system as safe, reliable, performant, and efficient as our own code? Well, the first thing we can do is design the SDK to locally evaluate our configuration logic. So the SDK fetches all the configuration logic from the server upfront in this one initial network request. And then after that, it locally evaluates the configuration without any dependency on the network. So it's very reliable, performant, and efficient. But we still have that one initial network request which could fail. So to make this more robust, we can include a snapshot of our configuration logic in our app bundle at build time. So the SDK can use that as a fallback in case it can't initialize from the server. And we can also set up a webhook to trigger a new build and deploy whenever the configuration logic changes. So we keep that build time snapshot up to date and fresh. And then if we do that, we don't even need to initialize from the server at all. And we can use the SDK in this local-only offline mode. But then we do lose the benefit of being able to update the configuration instantly. But then with this blended approach, we get the best of both worlds. So we have this fresh snapshot in the app bundle, but we also initialize from the server to get the latest configuration instantly. The next thing we can do is that when we evaluate the configuration, we can also pass hard-coded fallback values for the case when the SDK hasn't initialized and there's no snapshot. And then we can also ensure that the configuration's evaluated with full end-to-end type safety to avoid typos, catch errors at compile time rather than runtime, and then enable this great developer experience with like code completion, find all references, and JS comments. And then finally, we can version control all of the configuration logic in this Git style history. So we can see exactly what changed and when. And then we get clean diffs of all the logic and schema changes, and then branches to test and preview configuration changes before merging them into the main branch with a pull request. So it kind of just mirrors exactly how you work in your own code base. And then we can also layer on team roles and permissions to safely onboard non-technical team members by requiring that all their changes have to go through a pull request first. So to recap, with this local evaluation with the SDK, build time snapshots, the type safety, and Git style version control, we can get a similar level of safety, reliability, performance, and efficiency as our own code. There was no tool out there like this, so that's why we built Hypertune, and there are some links to check us out there. So yeah, why did we decide to work on this? We believe there's a lot of slow back and forth that happens in organizations during software development. There's a lot of waiting for updates to reach production, especially for apps with a slow release cycle, like mobile apps. There's a lot of low-hanging fruit to improve product conversion rates and just the overall efficiency of software systems, especially as they scale. There's a lot of complexity in those software systems that can be simplified, and there's a lot of slow software iteration. So we believe that app configuration, when it's done in the right way, can be the solution to a lot of these problems. So yeah, thanks for listening, and hope you enjoyed the talk.
Any questions?
Yep. Yep.
Any questions? Are you using something like object proxies to sort of reflect the types onto the client?
So it's just a code generation tool. So we take the schema that you define in the tool and then generate code based on that, basically. So yeah, no proxies or anything. Yep.
How did you make UI so smooth and light? And I see zero last, which makes me very aesthetic pleasure for just looking how you click it. Because sometimes you have all these slaggy things.
I mean, it's just a plain React app, actually, so nothing too fancy there. Yeah, I think the code base is pretty minimal. Like, we don't have like huge amounts of code executing on every render. So, yeah. I mean, if you want to, I can actually talk a bit more about that. Yeah, this like under the hood with this UI, it's like a full configuration language, like I talked about in the slides. So you can express any logic here, and so under the hood we express that, we kind of represent that as this abstract syntax tree of your logic in JSON, and then that's what you're manipulating when you change things, essentially. But it's all kind of pretty fast, yeah. Yeah.
Are there any plans to use LLMs to generate the text for the marketing copy?
Yeah, exactly. Yeah. I mean, you can already do that with ChatGPT. So you could say, what are some good discount copy variations, and then just plug them into the like a machine learning loop here. But yeah, that's something that we're thinking about. Yeah.
So you know your server, which stores all the data. Is there something you can stand up locally by yourself, or is it something you guys manage?
So do you mean that all this configuration logic here, or yeah?
So because you know, like you said earlier, that because every time you made a change, you have to run an NPS Hypertune to so we must be storing that data somewhere on some server somewhere.
Yeah.
Right. And I'm just wondering about that server. Is it something you guys is it something that you can stand up locally for yourself?
Got it.
Or is it something that you
Yeah, so you run npx Hypertune every time you make a schema change. And yeah, like your project schema and the logic for your project is managed like on our servers at the moment. But yeah, we're also thinking about making it easier to work with locally as well. Yeah.
I've got one question as well. So is this like
Mhm.
So when I'm running in England, I want a whole different set of configurations.
Yep.
And then when I'm running, say, for instance, in the US, I want a totally different set of configurations. I don't want to
Yeah.
is that possible?
It is, yeah. So it's pretty interesting because you can actually view all of the logic of your project as just a complete tree in the UI. So you can see it's just like one big abstract syntax tree, like a giant program. And so right at the top of your program, you could have like like an exhaustive enum switch on the environment or the country, for example. So here, for example, we could have whole different copies of your configuration for like these different environments. But this could just as easily be like a country enum, for example. Yeah. Yeah.
If you wanted to test different front-end looks for your app, is there a limit to the complexity where you could store non-technical people to be able to spot between? Is there any world in which they have like different layouts and they could select them, or is that too complex?
Yeah, that's kind of it's an interesting question. So yeah, but part of the reason why we designed it in this flexible way is that there's not really any limit to how complex the use case can get, because you can express this schema however you like. So it's basically under the hood. You can actually write it in GraphQL. So anything that you could express in GraphQL, you can build here. So you could, theoretically, you could actually encode the whole structure of your UI in here. And actually, that's kind of what we did at Facebook for like one of our projects. So, like we're always trying to kind of make mobile apps more configurable from the server side, because once they're shipped to the App Store, then you then have to go through a whole nother rebuild of the app, and then kind of wait for the long release cycle for Apple to approve it, which could take a couple of weeks. So there was this project to do something like this, where we encoded the whole structure and layout of the mobile app UI in a schema like this, and then we could just configure it on the fly from the server, even after the app had been shipped to the App Store. So yeah, you can get as kind of complex as that. Yeah.
We're going to have to take two more, I think, when we run out of time. So one at the back and one.
The machine learning groups for semantic topic allocation. Could you explain how
So under the hood, you can see. Okay, so when it's a test, you have these percentages for the different arms of your test. When you convert it to a machine learning loop, you see those percentages disappear, but instead you have to select this goal event type. So you can log analytics events to Hypertune, and then you can express a goal for the machine learning loop in terms of those events. So you could say, I want to optimize for upgrades. So what's happening is, as you send those upgrade events to Hypertune, and as it sees which variants users are getting, it can learn that, okay, this variant results in more upgrades. And then if you're passing in user features, it could also see, okay, it's performing better for this variant's performing better for these types of users, and this variant's performing better for another type of users. So yeah, it's just kind of doing that training in the background. Mm-hmm.
Please go ahead.
What is it using to make the location-based flag?
Oh, yeah, that's a good question. Yeah, so in your schema, there's basically two types of things you can define broadly. There's like the output types, like the feature flags, the discounts, and then the input types, so the things which you're passing into Hypertune, like the current user, the organization, and so on. So you would pass in the location just as an input type. Yeah.
Cool. I'm going to call time. We're going to have a 5-minute break now. Maybe you can catch up with Miraan in the break and ask a question then. We can have a bit of a conversation. It's going to be a 5-minute break because we started really late, and I know people need to get home, and some people have to travel far to Manchester or places like that. So grab a drink, grab some pizza. Thank you.
Cool. Shall I